Hi everyone, welcome to the 7th class of current electricity. In this lesson, we will learn a very important principle, Beadstone's principle. In the last class, we have learned Kirchhoff's laws and their applications. Today, we will discuss Beadstone's principle and its proof using Kirchhoff's laws. Beadstone bridge, it is an arrangement of 4 resistors, a galvanometer, and a cell. 4 resistors are arranged in the form of a rhombus. Okay. Out of these 4 resistors, one can be taken as unknown resistance. We will find out this unknown resistance. I will draw the diagram for you. Four resistors are arranged in the form of a rhombus. This is a resistor. Second resistor four resistors are arranged like this. This resistor I am writing as P, naming it as P. This is Q, this is R, this is S. And between points, I am naming this as these points A, B, C, D. Between B and D, a galvanometer is connected. A galvanometer is for detecting current. Galvanometer is used for detection of current in the circuit. Galvanometer resistance I write as G. And between the point A and C, a battery is connected. Between the points A and C, a battery is connected. A battery or a cell is connected. Suppose its EMF is E. This arrangement is known as Beadstone bridge. Beadstone bridge. Okay. And if the ratio of the resistors P by Q equals R by S, if this relation is valid, the ratio of resistance P and Q and R and S, if P by Q equals R by S, then no current will be passing through the galvanometer. Then the bridge is said to be balanced. Okay, when the ratio P by Q equals R by S, the point B and D will be at the same potential. So no current will flow through the galvanometer. Current through the galvanometer is 0. This condition is known as Beadstone principle. If the ratio P by Q equals R by S, no current pass through the galvanometer. Current through the galvanometer becomes C, I 0. I am writing current through the galvanometer as Ig. This condition is known as Beadstone principle. as Beadstone principle. This arrangement is known as Beadstone bridge. Okay. At balance condition, even if you interchange the positions and we can interchange the positions of galvanometer and the cell. If you connect the cell between B and D and galvanometer between A and C, then also galvanometer shows the zero current. Then A and B will be at the same potential. So current through the galvanometer will be zero. So Beadstone bridge is an arrangement of 4 resistors arranged in the form of a rhombus. P, Q, R, S are the resistors. See in the diagram, between the points B and D, a galvanometer is connected. Between A and C, a cell is connected. When the ratio P by Q equals R by S, then no current through the galvanometer is detected. Current through the galvanometer will be zero. Then the bridge is said to be balanced. This condition P by Q equals R by S is known as Beadstone's principle. Beadstone's principle. So here S will be an unknown resistance, a resistance wire. You can find out the unknown resistance. Okay. Now we can prove it. For proving, we can apply Kirchhoff's laws. Suppose the main current through the battery is I. Current through the battery is I. At the point A, current I is split into two, I1 and I2. And by using junction rule, by using junction rule, we can write total current is I1 plus I2. Current entering the junction is equal to current leaving the junction. I equals I1 plus I2. Again, at the point D, the current I1 again divides. I1 is moving to the point D. Okay. Here I1 again split into two parts. Ig moves through the galvanometer. Applying junction rule, I minus Ig will pass through the resistor I1 minus Ig. I1 minus Ig pass through the resistor Q. And you can see at the point D, Ig is meeting the current I2. So again, current through S will be I2 plus Ig. So we just applied junction rule. Now we can apply loop rules, Kirchhoff's second rule in the two loops. You consider the loop A, B, D, A, and you travel along the loop in this direction, clockwise direction, and traveling from A to B, B to D, D to A. Okay, so applying loop rule. In the loop, which loop I am applying? A, B, D, A. A, B, D, A. So I start travel along the path A, B, D, A. So, you know, I1 into P minus I1 into P, because I travel in the direction of the current. Then B to D, again traveling in the direction of current. That potential difference will be negative. So Ig into G. G is the resistance of the galvanometer. Then I reach D. Now D to A, I travel opposite to the current direction. So plus I2 into R equals 0. This equation number 1. So we applied loop rule in the equation, applying the loop rule in the loop ABDA. Now, I'm applying loop rule in the loop BCDB. In this way, I am moving. That is also clockwise. BCDB. For the loop, apply Kirchhoff's law in the loop BCDA. So I started moving from B, moving around the loop from B. I1 minus IG into Q. That PR potential difference is negative because traveling in the same direction. Then I reached from B to C, then C to D, traveling opposite to the current. So that potential difference across S will be positive. I2 plus IG into S. Then I am traveling from D to B. Potential drop is again positive. IG into G equals 0. In these two loops, there were no EMFs. So equation number 2. Now you know, when the bridge is balanced, current through the galvanometer is 0. When the bridge is balanced, current through the galvanometer IG is 0. So we can put this value in equation 1 and 2. Therefore, equation 1 become, put IG 0 minus I1P plus I2R equals 0. Or we can write I1P equals I2R. Equation number 3. Similarly, you put IG 0 in equation 2. So when you are putting IG 0, we can write equation 3 becomes minus I1 into Q. IG is 0 plus I2 into S equals 0. So we can write I1Q equals I2S. This equation number 4. Now if you divide equation 1 by 2, divide equation 1 by 2. Equation 1 divided by equation 4, not 1 by 2, sorry, equation 3 by 4. We are dividing equation 3 and 4. Equation 3 by equation 4, what you are getting? I1P by I1Q equals I2R by I2S. Cancelling I1, I2, you will get P by Q equals R by S. From this equation, we can find out the unknown resistance S. S is equal to R into Q divided by P. So we can determine the unknown resistance. If you determine the length of the wire and diameter of the wire, we can find out the resistivity using the equation rho equals pi R square S by L, where this L is the length of the wire, R is the radius of the wire. So this is Beadstone principle. Okay, state and prove Beadstone principle. It is an important topic for your board examination. Okay, so all of you learn it. Okay, it is an important one. Now we can do one numerical based on this Beadstone principle. I will give a question for you. I'm giving a circuit diagram. So four resistors are connected like this. All resistors have equal value. R, R, R. This point A, B, this point is C, this point is D, this point is E. Now you can identify how many resistors here. Count number of resistors. 1, 2, 3, 4, 5. In Beadstone bridge also 5 resistors including the galvanometer. 4 resistors and 1 galvanometer. Galvanometer resistance we take as 1. So there are 5 resistors. Here also there are 5 resistors. So we can rearrange this in the form of a Beadstone bridge. Here question is calculate the current through CD and current through the path CD and ACB. If a 10-volt DC source is 10-volt DC source is connected between the points A and B. Okay. Value of resistor R is 2 ohm. First, there was one more question. First question like this: calculate the equivalent resistance of the combination. Second is calculate the current through CD and AC. So first thing, just to look at that, you can see 5 resistors. Beadstone bridge also having 5 resistors, right? So we have to rearrange, redraw it in the form of a Beadstone bridge. How we can redraw? See, you see the end A, okay? That end you pull out and flip to the other side. Okay, you know the end A shown in the diagram, that end pull and flip to the left side. Imagine in your mind like that, then you can see a Beadstone bridge. Okay, I will redraw it. Then you will understand. Pull the end, pull the point A and flip to the left side of the circuit. Then you will get the exact Beadstone bridge. See, Beadstone bridge. Okay, so I am drawing like this after flipping. This resistor R, this point is C, this point is E. This is R, this point D. Okay. Now, this also I am drawing like this. Okay. This one I have drawn here, CD. Now, you pull the A2 and pull the end A and flip to the other side. So, how it will look like after flipping? This R will be like this, R. This A will come here. R. See, this is exactly like Beadstone principle. How many resistors? 1, 1, 2, 3, 4, 5. The middle one is instead of galvanometer. Okay, I'm naming it as in the Beadstone's bridge diagram. This resistor is P, this resistor is Q, this resistor is R, this resistor is S, and this was the galvanometer. Okay, and all these values are R only. So we have arranged in the form of a Beadstone's bridge, and at the point D, this terminal B is coming. B is pulled to the right side like this. So it is a Beadstone bridge. Okay. More clarity again, and drawing like this. Once again, like this. Okay. This point is A. This point is B. This is E. This point is C. This point is D. Okay, so it is a Beadstone bridge. Now you have to check whether Beadstone's principle is obeyed. All resistors are equal only, 2 ohm each. So P by Q is R by S only. Okay, that means Beadstone principle is satisfied. That means no current pass through the central path CD. So there is no current passing through CD. So you got the current through the path CD is 0. Current through the path CD is 0 because Beadstone principle is obeyed. Okay, so no current passes through CD. You want to find out the equivalent resistance. Then what to do? You can eliminate the central resistor. No current pass through the CD branch. So what you have to do? You have to remove that CD. So now I am removing that CD. Okay. Now you see, now it is easy to find equivalent resistance. You can see these two resistors are in series. And the lower part, two resistors are in series. Okay, first to find out series of the upper part, R and R, and series combination of the lower part. Then they will be in parallel. So we can again simplify the upper portion. You can write as R plus R 2R. Lower portion again you can write as R plus R 2R. And this is A. This point is B, and these two now are in parallel. So what is the effective resistance? R equivalent. You know the equation for parallel combination. R1 R2 divided by R1 plus R2. Here R1 is 2R into 2R divided by 2R plus 2R 4R. 4 cancel. Okay, and you are getting equivalent resistance as R only, right? 4 cancel R. So it is 2 ohm. R is given as 2 ohm. Okay. So we found the equivalent resistance of the combination. Now you need to, this is the first part of the question, equivalent resistance. Now you need to find out current through CD. That already found. Current through CD is 0. Now you need to find out current through ACB. ACB means this path. See ACB, this path. Between A and B, 10 volt is connected. So you can find out the current. Current is equal to potential divided by potential difference divided by total resistance of that path. So V was how much? 10 volt. 10 volt is connected. Resistance between A and B is how much? 2R. So 10 divided by 2. R is 2 ohm. So 10 divided by 4. So 5 ampere. 2.5 ampere. So this is very simple problem. Okay. First you have to apply the logic. First you look at the diagram. How many resistors are there? Okay. Then arrange it into the form of a Beadstone bridge. Okay. I will give one more question. One more question. Here a battery is connected. This resistance is 2.4 ohm. This is 2 ohm. This resistor is 4 ohm. Now here a resistor is connected. This is 10 ohm. Here there is a resistor that is written as X. And here there is one more resistor that is 3 ohm. This point is given as B, C, A, B. Okay. You have to find out the calculate the value of the unknown resistance and current drawn by the cell. Calculate the value of the unknown resistance. X and the current drawn from the cell. Okay, see, look at the diagram. You see the top circuit, top part of the circuit. You can see 5 resistors. So it is a Beadstone bridge only. You can arrange in the form of a Beadstone bridge. See the top circuit. This is P, Q, R, S. Okay. But it is given, calculate the value of the unknown resistance and the current drawn from the cell if no current flows through the path AD. If no current flows through AD. See, it is given through AD no current flows. AD is, instead of galvanometer, AD 10 ohm is connected. So no current pass through AD means you have to remove this. So we can remove this. Then you redraw the remaining. So I'm removing that central. So it will be like this only. Now see, you can find out the before that you need to find out unknown resistance. Okay, before drawing, listen, before removing. Now this is Beadstone's bridge and it is given no current is flowing through AD. That means we can apply Beadstone principle. P by Q equals, what is the Beadstone principle? P by Q equals R by S. What is P here? 2. Q is 4. R is 3, S is X. So cross multiply, what will be X? X equals 3 into 4 divided by 2 is equal to 12 by 2, 6 ohm. So you found out the unknown resistance 6 ohm. Okay. Now you have to find out the equivalent resistance. As I told you, since no current pass through the section AD, you remove AD. Now you can see the top P and Q are in series. R and S are also in series. They together in parallel. So you can find out that much resistance. Okay. So what will be the resistance of? How will you find out? R parallel. I am finding parallel resistance only. Parallel combination of resistance. 2 and 4 are in series. R1, R2 divided by R1 plus R2. This is the formula. R1 is P2 Q4. 2 and 4 series means 6. 2 plus 4, 6 into. Now, what is the other series to this 3 and X we found as 6. So 6 plus 3, 9 divided by 6 plus 3. So it will be how much you are getting? Sorry, it is 6 plus 6 plus 3, 6 into 9 divided by 6 plus 9. So how much you are getting? 54 divided by 15. This is the top parallel combination. Okay. How much you are getting? 54 by 15. It will be 54 by 15. 3 point something you will get. You will get 3.6 ohm. Okay. Now, with the cell, there is 2.4 ohm in series. Cell EMF was given as 6 volt. So, what is the effective equivalent circuit now? You can draw it as this EMF 6 volt. Here there is 2.4, and that parallel combination you replace by 3.6. Now you can find out the current, right? What is the equation for the current? E by R. I equals E. E is 6 volt divided by total resistance 3.6 plus 2.4. How much? 6. So 1 ampere. Okay. So this is about the Beadstone's principle and application. Okay, children. So we will stop today's class. Thank you for watching. We'll meet in the next class. Goodbye.